Hi everyone. Today I want to discuss about balancing chemical equation. So how to balance for any given statement or equation. So first of all, if it is given in the form of statement, then what we have to do? First step is translating the statement. The statement, for example, magnesium burn in presence of oxygen produce a magnesium oxide. So this is a statement. That statement we have to translate into equation. That is now magnesium formula symbol Mg plus oxygen symbol is O2 gives rise, this will be converted into magnesium oxide. This is the first step we have to do, translating the statement. Magnesium react with the oxygen, yield magnesium oxide. Second thing what we have to do, balancing the atom. So how to balance this? For example, this equation magnesium plus oxygen gives rise MgO. Then here we have to follow one trick. First start the balancing from the a complex compound or complex molecule. So what is the complex now? Complex molecule, meaning which has more number of different atoms. Start from which one? Complex molecule. Now we have here oxygen 2 atom, magnesium plus oxygen 2 atom, but it has different, this is the same, therefore this is considered as a complex. Now based on this we can solve one magnesium, here one oxygen, but here two are there, therefore we can make into, this is half. 2 half is 1, that's why left side 1 oxygen, right side 1 oxygen, therefore it is balanced. Now you can keep in mind this is a unbalanced equation. Then after multiplying with the coefficient, this is now balanced equation. Now the third one, what we have to, anyway this is a balanced, but half molecule representation is not the better way, therefore we have to adjust the coefficient and represent the coefficient in the simplest whole number instead of the fraction. So simplest whole numbers are preferable coefficient of the reactant or product. Half also okay, but preferable is which one, meaning the simplest numbers are preferable. Therefore now the third step is adjusting the coefficient. Then how to adjust this coefficient now? Now Mg plus half O2 gives rise MgO. This is the equation from the second step. Now I am adjusting the coefficient by multiplying with the second number, that is 2. Whole equation we have to multiply with the any one number, not individual reactant or individual product. You have to keep in mind whole equation we have to multiply with the same number. That is a point here, to make into the a simplest whole number instead of fraction. So keep in mind smallest whole number are preferable or simplest whole number are preferred. That is a third point. Next one, fourth point. What is the fourth point? Now you observe here first in third point, 2 into Mg, then what will get? 2 Mg magnesium, 2 into half, then that is a 2 cancel mean 1 O2 and 2 Mg according to the third step. Then fourth step, what is the fourth step here? Checking the atoms, they are balanced or not. According to this one, first I will check the reactant, next I will check the product. R mean reactant, P mean product. According to this, how many are there? Two magnesium atoms are present and one O2 molecule is present. Then we can say two magnesium atoms are present and two oxygen are present. So totally left side of the arrow mark, right side of the arrow mark, totally two magnesium and in one oxygen molecule two oxygen atom, then here right side also two oxygen atom, that is balanced. So checking completed. Then what we have to do next one, fifth one step is specifying the states of matter. It means their physical state. Then once again I am writing this as 2 Mg plus O2 gives rise to MgO. Now keep in mind this is also a balanced equation and this is also balanced equation, but which is preferable mean simplest whole number are preferable than the fractional one. Fractional also okay, but preferable one simplest whole number. Therefore magnesium we know that is a solid, then this is a solid S, and oxygen is gas we know, therefore G. Magnesium oxide is a solid, therefore yes. So keep in mind their physical state. Solid meaning we have to represent the S. Liquid meaning we have to represent the small l in the bracket, parenthesis, in the subscript. Next one, gaseous molecule mean you have to write the G. In case aqueous meaning you have to write AQ in the parenthesis. These are the physical state. So this is a simplest represent balancing method of any chemical equation. Another one also is there, that is called thermochemical equation. So thermochemical equation meaning, what is thermochemical equation? A completely balanced equation represented its heat of energy. Now a balanced chemical equation represented along with heat energy. In few reaction energy may be gain or in few reaction energy may be loss. So that loss or gain energy also represented, then that is a thermochemical equation. For example, this 2 Mg solid plus O2, this is a gas, gives rise to MgO solid. Magnesium burn in presence of oxygen is a exothermic reaction. So delta R enthalpy of reaction, this is negative. I don't know exact value, that's why I'm writing negative. Negative indicating exothermic reaction. In case if delta R, if delta RH enthalpy of reaction, if it is positive, then it is known as a endothermic reaction. This is a complete representation, that is heat energy represented, meaning that is thermochemical equation. If it is not, mean only normal chemical equation. That is a difference. Now, mistake to avoid in balancing a chemical equation. The first point, do not alter the chemical formula. For example, in the previous balancing equation, we have magnesium plus oxygen gives rise magnesium oxide. Then somebody they will do like this, magnesium plus oxygen gives rise magnesium oxide. They change the formula. Actual magnesium oxide formula, what is that? MgO. Now they are writing which one? MgO2 to balance the oxygen, oxygen, two oxygen, Mg balance like this. That is not acceptable. So this is wrong representation. The second step is do not add other reactants or product to balance. Example, now we have magnesium plus oxygen gives rise MgO. For balancing purpose, someone they may add extra oxygen like this. This is not acceptable because now 1 1 2 oxygen balance magnesium balance. This is not at all acceptable. Whatever the formulas are there, that will be remain. So don't add product or reactant to balance the equation. So whatever the statement given, according to the statement only we have to balance. Do not multiply any one reactant or only reactants, any one product or only product in the adjusting coefficient. We have equation is magnesium plus half oxygen gives rise MgO. So half is not that much preferable. That's why we are trying to adjusting the coefficient. Therefore, we have to multiply whole equation with the any number, but don't multiply in individual reactant or product. For example, somebody will multiply like this Mg plus half O2. Only reactants are multiplied and product not multiplied, when this is wrong. Otherwise, somebody will multiply like this Mg plus half O2 gives rise only products are multiplied, mean that is wrong. So which is acceptable? This is whole equation multiplying is acceptable, and any one reactant multiplying or only reactant multiplying is not acceptable. Then somebody will multiply like this also, Mg plus 2 into half O2 gives rise to MgO. This is also not acceptable. Only reactants are multiplied or only products are multiplied, or any one of the reactant or any one of the product multiplying is not acceptable. Whole equation should be multiplied. That is a correct representation of the or correct balancing of the chemical equation. So this is the a simplest method to balance the chemical equation. Other methods also is there, that is called ion electron method and oxidation method, but that you will learn in the redox reaction chapter. So that I am not mentioning here. If you want that, I will give here other balancing method. One is ion electron method. Second one is oxidation number method. Oxidation number method. Now whatever this solved is trial and error method. Trial and error method, that is generally used in this mole concept, because we don't know the how to balance ion electron method and oxidation number method. That comes in the redox reaction chapter. That time we can balance. but still we don't know that concept. Therefore, we have to use trial and error method.